Your FastMCP servers need a shared cache that survives restarts and works across multiple instances. But local storage can't handle that. We'll set up Redis as a distributed storage backend, showing exactly how to configure the connection with host, port, and authentication. You'll see the basic pattern for integrating Redis with FastMCP, plus key considerations for production like environment variables and the optional py-key-value-aio dependency.
From py-key-value-aio stores, Redis import Redis store. Cache store equals Redis store. Host equals Redis, example com. Port equals 6379. Password equals your Redis password.
This demonstrates the pluggable storage backend pattern, where FastMCP uses a standardized key-value interface to support multiple persistent solutions through a single configuration point. The pattern allows seamless switching between in-memory, disk-based, and distributed storage systems like Redis without changing application logic. The distinctive advantage is deployment flexibility. You can develop with simple memory storage, then transition to production-grade Redis by changing just the store initialization. The implementation works through the py-key-value-aio library's unified interface, where all storage backends implement the same async key-value methods. This specific example configures a Redis connection with host, port, and password parameters, establishing a networked cache that multiple FastMCP instances can share. Under the hood, the library handles connection pooling, async I/O, and Redis protocol details, while your code interacts only with the generic store interface. Redis provides critical production capabilities like distributed caching, shared state across servers, and built-in TTL support, though it introduces network latency compared to local storage. For production use, the official documentation strongly recommends wrapping the store in Fernet encryption wrapper to encrypt sensitive data, though this example shows the basic connection without encryption for clarity. The pattern's value becomes clear in multi-server deployments, where Redis eliminates cache inconsistency while the abstraction lets you upgrade storage independently of your business logic. Let's break it down line by line.
From py-key-value-aio stores, Redis import Redis store.
This imports Redis store, an async-compatible key-value store implementation for Redis that handles connection pooling and TTL support. It provides distributed caching for FastMCP deployments, with production requiring environment variables for secrets and the optional dependency, py-key-value-aio. Note this basic configuration omits encryption. Production should wrap the store in Fernet encryption wrapper as shown in the official docs, balancing network latency against security requirements.
Cache store equals Redis store.
Creates a Redis store instance for distributed caching in FastMCP deployments. This async-compatible store handles connection pooling, automatic reconnection, and TTL support while abstracting Redis-specific operations behind a consistent interface. For production use, wrap this in Fernet encryption wrapper as shown in the official docs, and move credentials to environment variables.
Host equals Redis, example com.
Specifies the Redis server hostname where the key-value store will connect. This is the network address of your Redis instance, required for establishing the connection. For production, store this in environment variables and ensure the optional Redis dependency is installed via pip install py-key-value-aio.
Port equals 6379.
Specifies Redis's default port 6379 for the connection. This matches Redis's standard port, ensuring compatibility with most Redis server deployments. For production, store this and other connection details in environment variables as shown in the official docs.
Password equals your Redis password.
This sets the Redis authentication password, preventing unauthorized cache access. Production deployments must store this in environment variables and should wrap the store in Fernet encryption wrapper as shown in the official docs. The basic connection here demonstrates the pattern before adding encryption. This closing parenthesis completes the Redis store initialization, establishing a connection to your Redis server with the specified host, port, and password. The configuration enables distributed caching for FastMCP deployments, with built-in async support and connection pooling, though production use should store the password in environment variables and wrap the store in Fernet encryption wrapper, as recommended in the official docs. Note that Redis support requires the optional dependency, py-key-value-aio, and introduces network latency compared to local storage, while adding TTL support for cache expiration. Redis storage configuration in FastMCP. This snippet demonstrates the fundamental Redis connection setup for distributed caching, where authentication tokens and cache entries persist across server instances. The basic Redis store configuration, shown here, requires the optional dependency, py-key-value-aio, and exposes credentials that should be moved to environment variables in production. Redis provides in-memory performance with built-in TTL support, trading minimal network latency for distributed consistency.
The cache that never sleeps must first learn to forget.